The universe is a mystery wrapped in enigmas, and one question stands out among all others. What is the true nature of our universe? Is it infinite, finite, or something even more bizarre? Scientists have been grappling with this problem for centuries, and the answers we have today are as fascinating as they are terrifying. It's not just about understanding where we live, it's about comprehending reality itself. Let's start with the basics. Imagine traveling through space in a straight line. Will you eventually hit a wall, loop back to where you started, or just keep going forever? This question might seem like science fiction, but it cuts to the core of cosmology. What is the shape of the universe? And does it have an edge? If it does, what lies beyond that edge? These are questions that have kept even the greatest minds awake at night. For years, scientists assumed the universe was infinite, stretching endlessly in all directions. But if that's the case, why isn't the night sky blindingly bright? This paradox, known as Olber's paradox, reveals a fundamental problem with the idea of an infinite, static universe. If there were infinite stars scattered across an eternal cosmos, the night sky should be lit up as brightly as the sun, with every line of sight eventually hitting a star. Yet, the sky is dark. Something doesn't add up. To resolve this paradox, we need to go back to the beginning, or at least as close to the beginning as we can. Scientists believe the universe began 13.8 billion years ago with the Big Bang, a singularity of incomprehensible density and heat that rapidly expanded. This expansion continues even now, stretching the fabric of space itself. However, the universe isn't just expanding, it's accelerating. Thanks to the mysterious force we call dark energy, galaxies are hurtling away from each other faster and faster. Here's where things get even stranger. The further away a galaxy is, the faster it seems to be receding from us. At a certain point, these galaxies are moving away faster than the speed of light. This doesn't violate Einstein's laws of physics because it's not the galaxies themselves moving, it's the space between us and them that's expanding. As a result, there's a limit to what we can observe. This limit is called the observable universe, which spans approximately 93 billion light-years. Beyond this, life from distant galaxies simply hasn't had enough time to reach us. But is the observable universe all there is? Almost certainly not. Most cosmologists agree that the universe extends far beyond what we can see. The big question is whether it goes on forever or wraps around itself like the surface of a sphere. If it's the latter, traveling far enough in one direction would eventually bring you back to your starting point. However, if the universe is infinite, you could travel forever and never encounter an edge. This idea is both exhilarating and terrifying. To understand the shape of the universe, scientists rely on Einstein's theory of general relativity. According to this theory, massive objects warp the fabric of space-time, creating curves. This curvature isn't limited to individual objects like planets or stars, it applies to the universe as a whole. There are three possibilities for the universe's shape. It could be positively curved like a sphere, negatively curved like a saddle, or perfectly flat. Determining the shape of the universe is no easy task. Scientists measure the angles of cosmic triangles formed by light from the early universe, recorded in the cosmic microwave background (CMB). If the angles add up to more than 180 degrees, the universe is positively curved. If they're less than 180 degrees, it's negatively curved. If they add up to exactly 180 degrees, the universe is flat. Current evidence suggests that the universe is flat, but this doesn't mean it's infinite. It could still be finite yet unbounded, like the surface of a sphere. If the universe is infinite, the implications are staggering. In an infinite universe, every possible arrangement of matter must exist somewhere. That includes countless Earths, countless versions of you, and countless variations of this very moment. Somewhere out there, There could be a version of you reading this script but wearing a different shirt or drinking a cup of coffee. The idea of infinite copies of ourselves might sound absurd, but it's a logical consequence of infinity. Even more unsettling is the possibility of a multiverse. Some theories suggest that our universe is just one of countless others, each with its own laws of physics. In some universes, gravity might be stronger. In others, stars might never form. The multiverse isn't just science fiction, it's a serious scientific hypothesis supported by quantum mechanics and string theory. But let's get back to the question of edges. If the universe is finite, does it have a boundary? And if it does, what lies beyond it? This is where our understanding hits a wall literally. Some theories suggest that the universe might be finite and enclosed within higher dimensional space. What lies beyond this hypersphere? That's a question we may never answer. Our brains are hardwired to think in 3 dimensions, so imagining higher dimensional space is nearly impossible. But physicists are undeterred. They continue to develop mathematical models that push the boundaries of what we can comprehend. One of the most fascinating aspects of this mystery is the role of dark matter and dark energy. Together, these mysterious substances make up about 95% of the universe, yet we know almost nothing about them. Dark matter acts like an invisible scaffolding, holding galaxies together, while dark energy drives the acceleration of the universe's expansion. Could these forces hold clues to the universe's true nature? Possibly. Another avenue of exploration is the cosmic horizon. This is the farthest distance from which light can reach us, given the universe's age and rate of expansion. As the universe continues to expand, some galaxies that are currently visible will slip beyond this horizon, disappearing from view forever. It's a sobering reminder that the universe is not static, it's dynamic and ever-changing. The sheer scale of the universe is enough to make anyone feel small. But there's something profoundly beautiful about it too. Despite its vastness and complexity, we've managed to piece together a picture of how it works. From ancient astronomers gazing at the stars to modern scientists analyzing the CMB, humanity has always been driven by a desire to understand. And yet, the toughest problem in physics remains unsolved. Is the universe infinite or finite? Does it have an edge? Or does it loop back on itself? These questions may never have definitive answers, but perhaps that's the point. The universe isn't just a puzzle to be solved, it's a source of endless wonder and curiosity. In the end, the toughest problem in physics is more than a scientific challenge. It's a reminder of our place in the cosmos. We're tiny specks in an incomprehensibly vast universe, but we're also part of something much greater. Whether the universe is infinite or not, one thing is certain: our quest to understand it will never end. So, if you enjoyed this journey through the cosmos, don't forget to give us a thumbs up and share this video with fellow space enthusiasts. Your support helps us continue exploring the wonders of the universe. Be sure to subscribe to SPACEEFIED and hit that bell icon so you never miss an update on our latest discoveries. Dive deeper into the mysteries of space by checking out our other videos, and let's keep the adventure going on together.